Decimal to binary. So we're done with memory units and measures, and now we can learn how to convert decimal numbers into binary numbers and vice versa. This module will be focused on the understanding of binary to decimal translation and the other way around. As mentioned in previous modules, always assume that at the lowest layers of programming, computers and machines only understand binary commands. So let's start with some basic examples. Before converting decimal numbers to binary numbers, we must first understand that unlike the decimal system, which is a base 10 system, just like our fingers, the binary system is a base 2 system. The conversion of decimal to binary, or base 10 to base 2 and vice versa, is an important concept to understand, as the binary numbering system forms the basis for all computer and digital systems. The fast and easy way to perform binary to decimal conversion would be using a binary to decimal online converter, such as in the following URL. There are probably thousands of binary to decimal calculators online, so you might just want to search on Google binary to decimal converter or calculator and select any of the available options. They're all pretty much the same. So here I can either choose a binary to decimal or decimal to binary conversion right here. We'll start with a decimal to binary conversion, and there is also a third option for hexadecimal counting, which is a base 16 counting system on which we will discuss in a later course. So here I can enter a decimal value, let's say 137, and then click on convert, and I'll get the values in either binary or um, hexadecimal right here. And there is another binary option which basically just adds 8 more zeros on the left, but as you can see on the right, the value is pretty much the same. And we can do vice versa, binary to decimal, and I can enter any random binary number and convert, and this is what I get. Now, if I move the 1 to the left, just like this, then this will be 102. So we have seen the automatic way to convert binary to decimal and the other way around. However, the manual way is trickier. Unlike the decimal system, which uses the powers of 10, the binary system works on powers of 2 as shown in the example on the right. Now, remember that binary numbers are traditionally read from right to left. So as you can see, the number 0 and the number 1 remain the same. But in order to write the number 2 in binary, we'll type 0, 1 from right to left, and then 1, 1 to represent the decimal number 3, and then 0, 0, 1 to represent the number 4, and so on. To understand how to count in binary, try to remember that the binary values are always calculated as a summary of 2 in the power of something. For example, in order to calculate the decimal value 13, we need to add 8, which is 2 in the power of 3, plus 4, which is 2 in the power of 2, plus 1, which is 2 in the power of 0. Now let's start with a simple one as a proof of concept. To convert a decimal number to binary, we will use the table on the right and follow the next steps. First step, choose a decimal number to convert. For this example, we'll use the number 165. In the second step, on the table on the right, find the number which is the closest to 165, but not higher, and mark it with a 1. Now we go from left to right to the next number we can add to 128 to make it either equal or lower than 165. In this case, it cannot be 64 since 128 plus 64 equals 192. However, 128 plus 32 equals 160, which is smaller than 165 and the closest we can get. We'll mark the number 32 with a 1 as well. We'll repeat exactly the same as above and mark the number 4, or 2 in the power of 2, with a 1. And again until we reach the desired number. All the remaining numbers should be marked as zeros. And there you go. 165 translated into binary is 10101010. I really hope you found this useful, and I'll see you in the next module, Memory Terminology.